Alright class, so here we are trying to make a review of acids, bases, and salts. Now, with every unit, I will give you a review sheet, and I'll do my best to try and use this trusty iPad to make a videotaped review. So, when you begin your review, you want to make sure that you read over and really have a firm grasp of these major understandings. Oops. Hello class. Here we are to review acids, bases, and salts. So I will try and use this trusty iPad to make guided reviews for all future tests. So when looking at our guided review, the same format applies as always. In bold, there will be our major understandings. The major understandings are things that you must know. And underneath the major understandings are the questions that test your understanding of all of these big ideas. I will not read the major understandings, but instead I will walk through each and every question to make sure you know how to solve it. Let's start with question number 1. In this question, they're asking us what the definition of an acid is. So the key word here is acid. What we should do is to use our reference table. So here we'll notice that reference table K has common acids. And when we look amongst the formula for the acids, we'll see that they all have hydrogen in common. This makes choice 1 our best choice. Moving on to question 2, it asks us about this formula, HNO3. So again, I'm going to use my reference table. Here on reference table, we'll see that nitric acid is indeed an acid. That means we can automatically eliminate choices 3 and 4. Now what distinguishes choice 1 from 2 is this term electrolyte or non-electrolyte. So when we review our major understandings, we can see above that they discuss electrolytes. Also, we'll recall that electrolytes are substances that conduct electricity in aqueous solution. Those include acids, bases, and salts. They are called electrolytes, and they conduct electricity because of their free-moving ions. So all acids are always electrolytes. That makes choice 1 our best choice. Moving forward, looking at question 3, in this reaction, ammonia, and they give us the formula. So we're going to match it up with the reaction here. So when we look at our choices, we see that ammonia is going, and it doesn't have any hydroxide or oxygen in this reaction. So in this case, we're going to remove choices 2 and choices 4. So we have to decide if ammonia is either accepting or donating hydrogen ions. So when we look at ammonia in its initial state, we see that it's NH3. And in the final state, it's NH4 with a chlorine. So obviously what has happened is that ammonia has accepted a hydrogen because it has one more in the products as compared to the reactants. In the next question, it gives us a reaction, and they say that when we add barium hydroxide to sulfuric acid, the electrical conductivity of the solution decreases. And they're asking why. Well, when we look at barium hydroxide, we'll notice that it's a hydroxide, and it's very similar to the common bases. And when we look at sulfuric acid, we'll see that it is a common acid. So when we mix an acid and a base together, what we do is we neutralize the solution and we form water. Now water is neutral, and we're asking why doesn't it conduct electricity? Well, something that conducts electricity is called an electrolyte. Again, electrolytes include acids, bases, and salts, and they conduct electricity simply because they have the free moving ions. So why did this solution not conduct electricity? Must be because the concentration of the ions decreased. Now, remember that when we mix together an acid and base, we always form salt and water. But with this salt, barium sulfate, that is not the case. That's because barium sulfate has an S after its formula, indicating it is solid. That indicates it is not soluble in water. Therefore, this salt is not an electrolyte. The next question has us looking for an Arrhenius base. Again, we must use our reference table. Refer to common bases. When we look at the formula of bases, I don't see any corresponding formulas, but what I do note is that most bases end with a OH. That would eliminate choice 4 and choice 2. Of the remaining two choices, I look again at the formulas and notice bases are metal hydroxides, so choice 3 is the best choice. Remember, if a formula starts with a carbon and ends with an OH, it is never a base. It is either this acid or it is an organic compound that is neither acid or base. Moving on to the next question, it's asked the only positive ion found in sulfuric acid. So we look at the formula of sulfuric acid from reference table K, and we see that sulfuric acid is H2SO4. Notice that there are 3 elements in sulfuric acid. We recognize this by the 3 capital letters. So whenever we have 3 elements in a formula, we have to refer to reference table E. On reference table E, you'll notice that sulfate here can be found in the sulfuric acid formula. Now sulfate has a charge of -2, and here we are looking for a positive ion, so sulfate cannot be the correct choice. Using reference table E, I then find sulfite. It also has a charge of -2 and can't be a choice. I look for the other ions. Here I notice that they also have hydroxide on reference table E. Hydroxide has a charge of -1, that it cannot be the choice. So hydronium ion, found here, the very top of reference table E, is the best choice. It is the only positive ion in the list. The next question again has us searching for electrolytes. Recall that electrolytes include acids, bases, and salts. So again, we're going to refer to our reference table. Looking at reference table K, we'll notice that hydrochloric acid is an acid. And we'll notice that sodium hydroxide is a base. So obviously, choice 2 is the best answer. In the next reaction, they ask us about a neutralization reaction between sulfuric acid, obviously an acid, and barium hydroxide, a base. Remember that in a neutralization reaction, we combined acid and base to form salt and water. So in this case, we're going to have sulfuric acid and barium hydroxide. They're going to react in a double replacement reaction. Now, the first step is to identify the ions. When examining both formulas, we'll see that both formulas are not binary. They have more than 2 atoms, or more than 2 capital letters in the formula. Thus, we must use reference table E. On reference table H, we'll notice that the hydroxide ion has a charge of -1, and the sulfate ion, which is here, has a charge of -2. So that means that the remaining particles will be